we can look at an equation and tell, we can't tell how many x-intercepts it has exactly, but we can definitely tell that it can't have more than a certain number. Okay, so that's why this is maximum number. You can look at an equation and tell the maximum number of times it can cross the x-axis. That's also important when sketching a graph, because otherwise, I mean, who knows, maybe it crosses 100 times, right? And then you wouldn't know exactly how to connect the curve. No, actually, it can touch more than twice. For a polynomial, it depends on the highest power, okay? Certainly, if it was x to the 100th power and a bunch of other terms, it could actually cross a bunch of times. Now, for an x squared equation, you're right. For a quadratic, it can only touch twice. And that's leads us to the rule, okay? So how can you look at an equation and tell the maximum number of times? It's based on the highest power. Kind of like when we're looking at leading coefficient of the highest power, except for x-intercepts, it cannot be any bigger than the highest power of the polynomial. So, if it's an x squared equation, it can only touch twice. Now, that doesn't mean it touches twice. It might only touch once. It might not touch at all. That means then it can only touch twice, but no more than that. That's all it means. So for like the x to the 100th equation, that means it could theoretically touch 100 times, but it doesn't have to. Might not touch at all, actually. Might touch 50 times, might touch 75 times, but it couldn't touch, for example, 101 times would be impossible. So let's take a look at a quadratic equation. And the first one we're going to look at is x squared plus 2x. So the highest power is 2, right? So that means it can't touch more than twice. Now, if we look at the graph, we notice it touches twice. Can you guys see that for a parabola, it's impossible to touch 3 times? Yeah, I mean, there's no way to take this shape and make it touch 3 times. This is for an x squared parabola equation. The highest power is 2. Yes. I'm going to show you next. If the curve just comes up to 0, it touches once. Now, does that violate the rule we just established? No. We only said the maximum number of times it can touch is 2. So in this case, it just touches once. It only has one x-intercept. That would not be an x squared equation. That would be an x cubed equation, which means it could theoretically touch 3 times. Yeah. Now, here's the third scenario. This is also a quadratic equation, x squared plus 2x plus 3. It doesn't touch at all. But again, it doesn't violate the simple rule. It's just saying it can't touch more than twice. So that's why it's called the maximum number of x-intercepts. We've already written this down, so you don't have to write it down again. But the key word is maximum. So when on your worksheet, all you have to do is see what's the biggest power. Well, that's the highest number of x-intercepts it can have. What's the highest number of x-intercepts this equation can have? 3. All you have to do is look at the highest power. Now, does that mean it has 3 x-intercepts? No. It just means that's the maximum number it can have. That's all you're going to put. When on the worksheet, you're just literally going to write max zeros or max x-intercepts, and then just write whatever that is. That way, when you go to sketch the graph, you'll know that it can't touch the x-axis more than that many times. It will help you connect the curve better. Here's what this particular graph looks like. And in this case, it actually does touch 3 times. So here's 6x minus 3x cubed plus 5x. Does it have to touch that many times? But that's the most number of times it can touch. Again, look at this shape. No matter how you move a cubic function up and down, it can't touch 4 times. It can only touch 3 times. Here's what the scenarios for x cubed look like. For the first scenario, it can touch 3 times. But notice if we move the graph down a little bit to where this just touches the x-axis, it would only touch twice. And if we move it far enough down, it will only touch once. For a cubic function, it has to touch at least once. It can't touch 0 times, unlike an x squared function. But still, the rule remains it cannot touch more than 3 times. Second example. Can anybody look at this equation and tell me the maximum number of times it's going to cross the x-axis? How do you know that? There you go. Even though you can't see it, it's a 1. So the maximum number of times that it can touch is once. So the answer is 1. What is this graph going to look like? What shape? Yeah, a line. Exactly. It'll look like this. If you think about a line, there's no way a line can touch more than once. Actually, you know what? Y equals 0 would touch everywhere, wouldn't it? It kind of violates that rule. Except y equals 0 doesn't have an x in it. So it technically doesn't have a highest power. Okay. That's just one of those weird things, I guess. Okay. One more example.
What if it's like 0 square root or like 1 0 power? But like so that just be y equals like 16 minus 1 probably. Like how would that work?
It won't touch.
Well, what if it lands on y? What if it lands on the x-axis?
I know, that's what I'm saying. I guess that's like an exception. Y equals 0 would touch everywhere, wouldn't it? Y equals anything else wouldn't touch at all. Okay. Okay. Yeah, that's true. Yeah. Okay, what's the highest power for this one? 4. So even though it's like being like it's a binomial to the 4th, it doesn't matter. The biggest power is still 4. So that means it's the highest number of times it can touch is 4 times. Let's take a look at the graph of this one and we'll be done. This one actually only touches twice. But again, it does not violate the rule which states it can't touch more than 4 times. Actually, it doesn't touch at all. I was looking at it wrong. The x-axis is down there. Whoops. So just because it has a power of 4 doesn't mean it's going to touch it all. In fact, it touches none. So on your worksheet, real quick, you got about 3 minutes. Just write down the maximum number of x-intercepts for those problems.